Problem number 6-8. If the vectors E1 equals 1, 0, 2, E2 equals 0, 1, 0 and E3 equals -2, 0, 1 form an orthogonal basis of three-dimensional real space R power 3, then vector U equals 4, 3 and -3 belongs to R power 3, which is three-dimensional, can be expressed as, we have four options. Option A, U equals -2 by 5 E1 -3 E2 -11 by 5 E3. Option B, U equals -2 by 5 E1 -3 E2 plus 11 by 5 E3. Option C equals -2 by 5 E1 plus 3 E2 plus 11 by 5 E3. Option D equals U equals -2 by 5 E1 plus 3 E2 minus 11 by 5 E3. It is a problem designed on concept of basis. We have 3D space. For that three-dimensional space, which is E1, E2 and E3 are members of basis. From previous videos, we know that concept of basis in this problem, in this problem, basis B is consisting of three vectors of dimension 3. So we can write basis as, in a set, this is set, basis in a set E1 into 1, 0, 2, E2 0, 1, 0 and E3 as -2, 0 and 1. Here in this problem, our vector is with three components. Each vector consists of three components. Now our vector is with three components. So our vector are three-dimensional space. So E1, E2, E3 are the members of the basis as per the concept of the basis. If we take any vector from our vector space, that vector is possible to express in a linear combination of E1, E2, E3, and if the vector 4, 3 and -3, a vector from our vector space, we have to express 4, 3 and -3 in the form of A E1 plus B E2 plus C E3. Now we will express in the form of vector space, which will become 4, 3 and -3, which is equal to A 1 0 2 plus B as 0 1 0 plus C as -2 0 and 1. And this complete process is called, we already know from basis, which is called spanning. Now in options we have E1, E2 and E3, which are vectors. So our job is to calculate A, B, C values. So we will equate. So equating LHS is equal to RHS for values 4, 3, -3 is equal to A plus 0 -2C 0 plus B plus 0 2A plus 0 plus C. We will equate B. B will become 3. Now from B we will get other values like A minus 2C is equal to 4, then 2A plus 2C is equal to -3. After multiplication it will become A minus 2C is equal to 4 and 4A plus 2C is equal to -6. Now we will add. It will become 5A. It will cancel out, equals to -2. Now A will become -2 by 5. Now 2 into -2 by 5 plus C is equal to -3. We will get C as -3 plus 4 by 5, which is equal to -11 by 5. Now finally we have A value as -2 by 5 and B value as -11 by 5 and B value as 3. So correct option is D. Correct option in this problem we have as D. What we have done in this problem is we have written spanning, that is 4, 3 and -3, which will be equal to A into E1 and plus B into E2 plus C into E3. It is it is called spanning. It is written only when our vector space is three-dimensional and we have three vectors in our vector space. Then only this linear combination is possible. Suppose our vector space is three-dimensional, but in the basis we have only two vectors. Like if we have E1 and we have E2, then this spanning is not possible. We can write only subspace. Subspace means B equals, in a set we have vectors E1, E2 and E3. This is subspace of R power 3, as our vectors E1, E2, E3 has three elements.